guys, this is Tim back again with another video, and this tutorial is actually quite interesting because I had already recorded it, and then I was discussing this technique with Arjan from House of Secrets, and House of Secrets is a studio that I share an office with, and Arjan also does Houdini stuff, and he's really good. He's super technical. Anyway, so I was talking to him and showing this technique, and we were talking about cops a little bit. And he was like, "Oh, yeah, but you can also do the same inside of cops." And when you're doing it in cops, it also opens up a lot of other really cool functionality. And I didn't know about this, until I talked to him about this. So I'm going to record this tutorial, and I'm going to show you both ways to do this. So the way that I was doing it was with Heightfield, which is a little bit more interactive. And then I'm going to show you the way, he showed me with cops, which is more flexible, probably for a lot of stuff. So the tutorial certainly got a whole lot more interesting, and it even taught me some things. Also want to give a shout out to Arjan and House of Secrets. So they used to be a VFX company, and now they do mostly real-time stuff, and they have a lot of cool stuff done in Unity. And they have this game called Kin, which is awesome, and I recommend you play it. So it's on Steam, and you can play it in VR as well. So I suggest you check that out. And I want to give a big thanks to Arjan for pointing out this technique. It has been super helpful. So anyway, I'm going to dive a little bit about generating displacement maps real time inside of Houdini from geometry, and then you can use those displacement maps to basically displace your geometry on the go. So as I mentioned before, I did it before in Heightfield, and I have already discussed that part in a tutorial I did a while ago. So I made a tutorial on Convergent, which was a short project that I did, and this used this technique. A lot of people seem to have found that technique interesting, but because it's like in a long form factor, not everybody might have noticed it, because this tutorial has a lot of stuff in it. And if someone is looking specifically how to do this, I thought it would make more sense to have a specific video about how you can do this. So it's just easier to find and to refer back to when you need it. So without further ado, let's dive into Houdini, and let's build it. So before we build anything, please hit the thumbs up. That really helps recommend this video to more people, so that really helps out the channel. And also I would like to remind you that all of the source files for this are on my website, timvanhelsdingen.com, and Patreon supporters will be able to download them. So if you're logged into Patreon, your Patreon supporters should be able to download all of the source files to this video. So without further ado, now let's start building. All right, so let's first do the Heightfield technique for this. So let's create a grid. Let's dive into this grid. And now let's make a sphere as well. I always seem to mistype. Let's make it a polygon and up the frequency a little bit. Now let's merge it in. All right, so now we have this. And now let's say we want to start using this as a displacement map to map this on another surface, for example. So what we can do is create a height field. And let's make the height field the same size as our grid. So let's copy the size and let's paste that into our size of our height field. And let's make the grid spacing like a lot higher. So now we get a 800 by 800 height field. So we have this height field here, because like if I make it too big, you can see I don't have enough resolution to capture it. And let's use height field project. So if you just type height project, you get it. Let's plug the height field in, and then let's plug the geometry in. So then we get this. Now let's make a null, so we can refer to this thing later. And then we want to put down a composite network to do this in. So you could either do this inside of the image network, or you can make a cop network over here. Doesn't really matter where you do it. So let's do it in here, and let's dive in, and then type let's type SOP import. So we're going to import a SOP in here, and let's then copy the path of our out. So you can, if you copy this, and then you can paste the path into this thing over here. So then when you already see something appear, and then you kind of want to set the resolution from SOP. So that means the resolution will be set from the Heightfield. So you can see if you middle mouse over the Heightfield. So the Heightfield was 800 by 800. Now the resolution is set from that thing. So if I were to make this bigger and then set resolution from SOP, now you can see it will change the resolution based on what I'm doing. So, but you can see something that, like, I already got a height map now from that thing. So if you look in here, you see a very nice height map generated from my geometry. And this is all interactive. So if I were to scale this sphere up and down, you can see that it's updating live. So it means you could animate this, and then this will also animate, and then now we can start using this inside our shader. So let's start doing that and then apply it to something. So as always, I'll be using Redshift to do this, but you can do it in any other render engine as well. I mean, it will be somewhat similar. I just generally use Redshift myself. A lot of you are also using Redshift, so I'm just going to do it in Redshift. But again, any render engine will be able to do this. It's just going to be displacement maps. So let's make a type RS and then material builder. So you're going to get a Redshift material builder, and then we're going to dive in here. So I'm going to maximize this view so it's a little bit easier for you to see. Now let's just put down a material, just so we have a basic material to go on our thing later. And now let's type displacement. I'm going to put down a displacement. We're going to plug that into our displacement here. And now we need to have a texture to go in here. So we can just type texture. Of course, we don't really have a texture, but we're gonna use what we just generated as a texture. So I'm gonna make this smaller again. So I want to refer to this thing. So maybe let's type a null so we have something easy to refer to, and type it. Let's call it out. Now we're gonna drag this into this box. You could also copy it and then paste it, and then it'll also give you the path. But by default, this will not work, because it's an internal operator. It's not, this is, by default, this will think that it's referring to a texture on disk, so it will not work. So I need to tell it to treat this as an internal operator. And I can do this by typing OP and then the two dots things, which I have no idea what they're actually called in English, but whatever. So OP and then the two dots, and then press enter. And now technically this should work, and then I should be able to use this as a displacement map. So let's try that out by applying it to something maybe. So I guess let's make a grid. Let's project a UV on it. So we have something to project on. Initialize it to best plane. And let's put our material on it. There we go. So we put it on there. And now let's go to the render view, I guess, and then press render, and then hopefully it will work and not crash and do other weird things. Okay, it's rendering, but I forgot to turn on displacement and stuff, which will obviously not really help. So let's turn on tesselation, turn on displacement, and let's maybe also put our camera like this and zoom out a little bit, and maybe we'll just do a let's make, why is the redshift shelf tool not there? I'm not sure. Let's do a light dome so we have a little bit more light in the scene. Now let's go to the render view and click render again. Oh, I clicked the wrong render button. I want to click that one. Now you can see it's starting to displace. So I want to turn up the maximum displacement, probably maybe change the scale a little bit. So you can see I'm actually now displacing based on the thing that I made before. And this is, well, it's just now treated as a displacement map. You can see it's a little bit like, it's maybe the resolution of the height field should be higher to capture the detail completely. But of course I can also like tile this now because it's just being treated as a texture. So I can go in here, I could type 3 by 3. I get a 3 by 3 displacement map. And I could like go in here and I could change some stuff. So this will not refresh instantly. So if I do this, it will not refresh by default. So I need to reload my scene. If you're doing this during render time, it will work. But you can see this is pretty cool, right? And I mean, all of the displacement updating itself will of course work fine. And I can use all kinds of cool height field techniques on this as well. So I could use just a height field blur. So I could blur it out a little bit. Probably by default the blur is like way too high because my scale is of course, let's make these three a little bit smaller. Because the scale is of course, yeah, really we're working on a really small scale on height fields are usually meant for terrains. So you don't really, so you need to use much smaller scales for this. Or maybe if we blur it out a little bit, we get a nice sort of smooth edge, which might be nicer for what we're going to do. So I guess let's go back in here and let's press render again. Am I looking through the, yeah, okay, like that. So this is a pretty cool technique, and you can of course apply this to anything you want. And because it's just treated as a regular texture, I could also plug stuff into the offset to manipulate whatever I'm doing. So I could use some of the new Maxon noises, for example, and I could just like take this and then put this in the offset, and now it's gonna act really weird, but I probably need to turn down the contrast. Maybe you turn up the scale. All right, you can already see stuff appearing, but kind of, okay, I need to make it a lot more negative. But now you can see it's working. Maybe change the scale a little bit. So you can use any technique that you would on a regular displacement map. But now this is being generated from our geometry. And again, if our geometry is animated, like a particle stuff moving across the surface or something like that, this will render out as a animated displacement map. So quite a cool technique. So that's the way I used to do it. Now there's another way to do it, and that's what I'm going to show you now, which has a lot of other cool functionality as well. So I guess let's call this Heightfield placement. Now let's do it in well, with the other technique. All right, so I guess let's copy and paste this one and call this cop displacement, like that. I guess let's dive in and remove our height field thing because we're not going to use that, but we are going to keep our out and let's just connect it straight to our geometry, so we don't need the height field anymore. All right, so I guess let's go in here, copnet, and have I turned off my rendering because it's a little bit slow? Okay, it's not. Okay, let's go into our copnet. Let's remove this thing. And we can keep the out node, I guess, because we're just going to put something new in here. So if you go in here and go to effects, and then why can't I see the entire thing? We want to FOB cop to generator. So let's go in there. Let's plug it into that thing. So we can just use VOPs inside of this thing. And so inside of here we're going to use cops in order to do some fancy magic in order to generate our height field in a different way. All right, so I'm going to maximize this. So we have a little bit more room to work with, I guess. And then what we're going to do is we're going to use an intersect node. So let's put intersect. And this is going to check for intersections, basically. So we're going to give it 2 inputs. So the first input will be our file. So let's do a parameter, and let's make it a no, let's do it. Sorry, let's do a constant. Let's make it a string, and then we're gonna point towards our geometry path. So again, remember, because this needs a file, and because our CopNet doesn't have an input, we're gonna need to point to it manually. And remember, like reading a file is basically just pointing to a string. So that can be a file on disk or wherever. So if we're gonna point towards an internal operator, we're gonna use the OP thing again, right? So let's type OP and the double dot thing. Then let's type a backtick and another backtick. And then between these backticks, we're gonna type OP full path. I'm gonna point towards a full path. Then we're gonna point towards, so we're gonna go up a couple of levels. And we're gonna go point towards our out. So we're gonna point towards basically our out of our merged grid plus sphere thing, right? So that's this thing. We're pointing towards that thing. Right, so let's put that inside of our file. Now we need array origin and we need array direction. So this is going to be basically okay, what's going to be the origin and what's going to be the direction that we're going to project from. So our array direction will probably be we're going to project from the bottom or the top. I guess let's do the -10. And our array origin will be from our image basically. So but we need it to be a vector. So what we can do is we're going to say float the vector. And we're gonna, so we only have X and Y components because this is just a 2D image, right? It's not a 3D object. So, and we're gonna ray trace basically some stuff from our scene into our COP network. I'm trying to explain this the best I can, but it was a new technique for me as well. So anyway, so what we need to do is we're going to put the X into the X component here, and then the Y, we're going to put it into the Z component. And then we have a vector. And then we want to fit range this vector. So this is basically gonna fit the size of the image that we're gonna project. So we need to basically give it the size of roughly what this thing is. So we're just going to type some manual values right now, and then later we can sort of link it up to the size of our actual grid. So it's just automatic. But let's just first do it ourselves. Okay, so what we kind of want to do is we want to, if we look at these values, so and you look at the thing here, so a couple of values will be negative and some will be positive, right? So on one side it will be negative. So let's say -2 or something. I'm not sure. So let's say, yeah, okay, -2. So it will be 2 meters, and then +2. And then also on the other side, -2, +2. And then we need something to say to determine the height. So I guess how high will we look for our projection. So let's also just say 2 or 1 or whatever. But so let's put -2 there, and from -2 to 2, from -2 to 2, to 2 to 2 to 2 to 2. So I'm doing a tutorial rap, I guess. Anyway, so and let's put this thing from the estimation min and max, both being 2. And let's put that into the ray origin. Right, so now we're checking for intersections. This is basically how ray tracing sort of works. So now we have a position vector, and we need to determine the distance from this, because we want it to be just a black and white image. So let's type distance. Let's put the distance in here. from the intersection, and we're gonna check so the distance between the intersectant distance and so the intersectant position and our original image position, and then we're gonna put this thing into our RGB values, and hopefully this will work. Let's go up a level, and let's make the image size like 1024 by 1024. You can see it's completely white. We do see something. You do see something, so it's probably just too bright. So we probably need to fit this output. So let's disconnect these, I guess, and then put a fit range. And let's put this one in, and let's put then this thing into RGB. And put the source max, I guess, to maybe something like 10 or something. And we can 8. And then you can see we basically did somewhat the same as we did before. So we have, oh no, I messed it up again. Let's go up a level. So we probably need to tweak a little bit of stuff. You can see there's some black bars there. I'm actually not sure why it doesn't match up, if I'm completely honest, because the values do seem to match up. And I guess what we need to do is we need to maybe just increase these values a little bit. 0.2 and 2.2. So I think, yeah, now it seems to, no, it still doesn't fit. Maybe it needs to be smaller. So minus and minus 1.75. And then also, that's also 1.75 and 1.75. All right, so now it seems to fit within the borders. Something else we probably want to do is we don't, like right now, also, like maybe, right now it's like a little bit offset for some reason. So I guess maybe we could also, I guess, just make the grid a little bit bigger. Let's just make the grid a little bit bigger, YOLO. Whatever. And then just make this -2 to -2. So now at least we're sure that it will capture the entire size. All right, so now you can see this is correct. So another thing is that we kind of don't want the background to be gray actually, because else it will also displays that. And I guess we only want the sphere to be displayed. So maybe we don't want this to be B2. Maybe let's make the destination minimum just a very tiny value here. So minus dot blah 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 blah. So this is going to be the Y projection, and I guess we can change some of the source max inside of here. All right, so now we created a displacement map. And now what we need to do is we go into our material, and we're going to copy our out from our copnet here. We're going to put this into, plug it into our shader there, and then let's type OP and then double dot. So same as we did before. Now let's test it out. So let's go to our, let's put our camera like this, and let's press render. And you can see this is working. So let me, you can see this is working. So yeah, okay, it's doing it from the correct one. I was just gonna check because, yeah, I mean, we also had the other one. Let's just to be sure, I guess, if we delete the Heightfield displacement, this should still work. Yeah, you can see it comes from our cop thing. You can still, you still have these little like problem areas, but that's of course because of the the resolution also of our cop network. So I guess probably we could make this a lot higher resolution. So I guess we could make it 4192, 4192. Now we have a much higher resolution displacement. Let's see if that actually makes a difference. Doesn't make that much of a difference. Maybe what we want to do is we want to maybe have more subdivisions, and let's change the minimum edge length. But again, because it's cops, we can also, like we did on the Heightfield, we can also just blur stuff in cops. Let's reload. So it's working. I guess we do need it to blur it a little bit. So I guess let's go into cops. It's thinking a little bit because right now we have kind of a high resolution image. I probably want to make it this a little bit lower again because it's just faster to work with a lower resolution. So I guess there's something for blurring. Yeah, there is. Okay, that's cool. Let's put it in there. Go to composite view. So I guess let's view that. You can see this gets blurred. Right. So now technically we should be able to, if we render, then that issue should be a little bit less. I think probably, most likely. Yeah, you can see there's the issue is a little bit less. All right, so that's another way to do it. And now the really cool thing about the technique that I just showed you is, which is not possible with Heightfields, is that we can also extract other attributes and put it in cops and then use it in our shader. So let's try that. Right, so let's go in here and maybe assign some colors to our objects. So color, let's make our sphere red, and let's maybe make our plane, let's make it green or something. All right. So green and red, beautiful. Best thing I've ever made. Let's go in here. Let's go in here. Let's type primUV. So there's another function that I have actually never really used myself. So it's primitive attribute. So it's called, when you type just primitive attribute, it will come down as primUV. So we want to go over here. Let's move it a little bit. Let's go ahead and put our UVW coordinates. Let's put them in our UV. Let's put the file. Wait, let's maximize this whole thing, by the way. Let's put the file. We want to use the same file, and our primitive number, we want to be this primitive number. Now, what do we want to extract? We want to extract the color. So that's going to be this thing here. Now I guess we can bind export this to be, and just give it a name called color, for example. There we go. And now let's minimize this and go to composite view. Now we have, if we look at color, you can see we have our red from our color. And of course we don't see our green. That's because if this allows us to go in here, it's because we changed this thing. So if I try to put it like this, now you can see we have color. So we can also use this color inside of our shader to do some other cool stuff. So let's try that. Right, so now we need to go up a level, and then we need to do some stuff. So we need to delete and put it after our blur here. Now let's put it to color, and we want to delete non-scoped planes. So we need to just get your color. Then we need to rename this color to something that redshift understands. So we're gonna put it from color, and if you rename it to C, then redshift will understand it. Also, it will just, if you try this with color, then redshift will just crash. I don't know why, but that happens. Anyways, we put an out, and then let's type out CT, I guess. And then in here, in our material, let's put a texture. Let's put redshift texture and put it in diffuse color. And then let's copy and paste our out CD, put it in there. And in front type OP, and then the double dot thing. And then layer gonna be C. Now technically this should work. So let's hope that it does. All right, so I guess we can now head up a few levels. Go to render view and press render, I guess. Let's see. Right, so there's a couple of things wrong here. So so what we did is, of course, let's go over in the COP network. So of course we changed this back. So right now the displacement will be wrong, but we can change that in the shader as well. So we can go onto displacement and we can just remap these values. So I guess remap them from -1 to 1, and then from 1 to 0. So they won't be inverted. Let's press render. Maybe reload. All right, let's see if this actually works like we want it to. So it shouldn't displace the grid itself. It should not. Yeah, as you can see, this is working now. So now we don't have the weird displacement thing. So yeah, now we're extracting both the color and the height. So you can see how this is very powerful, because you can use this this preview V. You can use this to extract any attribute. So any attribute that's on your geometry, you can use this to get it into your shader. Of course, it doesn't have to be a vector attribute; it can be any type of attribute. So you can imagine how powerful this can be. So this was really like when I heard about this was just really cool, and it opens up so many possibilities. And now I'm wondering why I didn't know this before. So yeah, really hope you found this tip interesting as well, and I'm going to use this everywhere I can now, probably. Right, so I really hope you found this whole thing helpful. It sure turned out to be a lot longer tutorial than I initially thought. It was called a quick tip before. The initial tutorial was like 12 minutes, and then with the whole extended stuff in there, it turned out to be a lot longer, but a lot more interesting as well. So if you want to download the source files for this, you can do that on timvanhelsdingen.com. If you're logged into Patreon, you should be able to download them, because the source files for my tutorials are for Patreon supporters only. So if you're not a subscriber on Patreon, there's a button there where you can subscribe, and that really helps out the channel, because that allows me to put more time into these tutorials and help me to maintain a more frequent release schedule than I used to do. So also, if you like this video, make sure to hit the thumbs up. That really helps out the YouTube algorithm, and then more people get to view my tutorials. And also, if you want to stay up with the weekly-ish content that I'm now putting out, make sure to hit the bell icon and to subscribe and hit the bell icon, and then you'll be notified whenever I post something. For example, I'm working on a introductory course for Houdini right now, which I'm super excited about. It should be out hopefully in a couple of weeks. A lot of work, but turning out pretty cool. And what I'm aiming to do with that is that it's going to be a beginner course, building up from completely the basics up until more advanced stuff. But the cool thing is that it's aimed at beginners, but we're going to create a super high-end end result just with super basic techniques. That's what I think some introductory courses lack, is that they show you basics, but they don't have an interesting end result. So it doesn't make it's much less interesting to follow along if you don't get a super cool end result. So we're gonna really build a super high-end VFX shot just with basic techniques. So I'm excited for that. It's not done yet. Will hopefully be out in a couple of weeks. I'm not sure yet when it'll be done. I'm working hard to make it happen. So yeah, make sure to subscribe and hit the bell icon if you want to know when that's out, or whenever I'm posting other cool stuff. So yeah, thanks for watching, guys, and see you in the next one. Peace.